enzymes catalyze reactions. They can be membrane transporters. What does that mean? They move things across cell membranes. The chemistry of the cell membrane, the interior part of the cell membrane is hydrophobic. What kind of molecules, polar or nonpolar, are hydrophobic? Nonpolar, right? So that means anything that is polar, hydrophilic, cannot pass through that phospholipid bilayer. So it has to be carried across. Things that are nonpolar can just go right through. So you've seen, I saw a commercial last night for it. The patches they use to help you quit smoking. Nicotine, like Nicoderm or something, right? Nicoderm, yeah, they put them right here. So tell me about the chemistry of that molecule, the drug. Polar or nonpolar?
Non-polar.
Got to be nonpolar, right? Because it's passing right into my body through cell membranes, right? Things you have to take orally, right, must be polar, right? Or whatever, and even that can cause problems, right, with absorption because we need to have a way to transport them across that, keep it that way. So anyhow, just kind of neat little thing there. They can be signal molecules. What's a signal molecule? A hormone obviously is a signal molecule, but so is a neurotransmitter. So are these things that are called paracrines, which just affect the local cells. We'll talk more about them. That's on Wednesday. I erased it. That's one of the things we'll talk about on Wednesday, is that whole kind of cell-to-cell communication. It's really kind of cool. They can be receptors. Receptors are just molecules that the signals bind to, right? You would never know, or a target cell, thank you, Anson, a target cell would never know, so to speak, that there's a signal out there if it doesn't have a way to recognize the signal, and that's what the receptors do, they recognize signals. Binding proteins, I don't really know what they're trying to get, what in regard this means, binding proteins. I consider a receptor a binding protein, but I suspect this has something more to do with binding of like filaments to cell membranes to help form an anchor, cytoskeletons, and things like that. I don't really know what they're getting at with binding proteins. Immunoglobulins, right? Immunoglobulins, these are proteins that function somehow in immunity, right? In particular, things like antibodies. You've heard of antibodies, right? They're proteins. We'll chat about that a little bit later. And regulatory proteins are proteins that, as the name implies, regulate some process. They could be things like we call cyclins that regulate cell division, things like that. They just regulate other processes. So they may not be responsible for carrying out a particular function, but they regulate other compounds that are responsible for carrying out a particular function. Oftentimes we call them modulators. You'll see that word a lot too, modulate. So, you know, modulation I like to think of as a volume, right? You know, like a TV or a radio or whatever's got an on-off switch. That's you either get it or you don't. But if the switch is on, you can get more or less of something. That's called modulation. So that's the more or less. So these regulatory could be things that turn on and off, but they could also be modulators that enhance or depress a reaction that is occurring. Right?